Hi, I'm Engineer Elton Ian, your instructor in the Computer Technology, Com 200 Electronics 2, under the College of Industrial Technology, Negros Oriental State University, Bayawan, Santa Catarina campus. In this video tutorial, we are going to discuss the basic power supply.
Yes, it's Engineer Elton E&M Home, Com 200 Electronics to Instructor. Now we're going to discuss the basic power supply. Now the main objectives of this module is the students will be able to understand the basic functions of its devices and parts used in the power supply, and able to measure the actual voltages along its components of the power supply, and the students will recognize the waveform created by each device using digital oscilloscope. Now to start with, we're going to discuss first what is the meaning of this power supply. Now the first meaning from sciencedirect.com, a power supply is a device that converts one voltage to another, more convenient voltage, while delivering power. And the second definition of the power supply is a component that supplies power to at least one electric load. Typically, it converts one type of electrical power to another, but it may also convert a different form of energy, such as solar, mechanical, or chemical, into electrical energy. Now, example for solar is our way of converting to electrical is our ultraviolet rays from the sun is converted to uh, electrical energy using our solar panel. For mechanical, usually generator, turbine, uh, moved um, by the piston ring, or by the water, or by the steam from the volcanoes, and converted into electrical energy through the revolution per minute, or the RPM of the uh, mechanical or the machine. And the chemical, usually the battery, composed of the electrolytes, or what we call the battery solution, is being used to store energy and converted into electrical, usually for our devices, usually cell phone, um, any device or loads that needs electrical charge from battery, and so on and so forth. Okay, so next is we're going to discuss what are the parts of the basic power supply. So the first part is the transformer, the second is the diode, the capacitor, the resistor, the LED, and the regulator. Now transformer, usually the function of this transformer is a step down transformer, because it has the input of 220 volts, and at the secondary voltage reduced to specified amount of voltage. Example, 12 volts, 9 volts, 6 volts, 5 volts, 3.3 volts, and so on and so on. And the diodes will convert the alternating current to the direct current, or usually the positive cycle of our AC signal. And the capacitor is to filter out the uh, positive sign or sine wave cycles of our AC signal, and to become almost what will be the desired output of, uh, of our device that is required. And for the resistor, usually used in LED, in series with an LED, and for the LED or the light emitting diode will not be damaged. So this is the purpose of the resistor, to protect your lead from large amount of voltages. Example, our transformer have the 12 volts. So the resistor will drop the voltage to almost uh, around 10.7 or 10.3. Uh, the voltage of our lead is only required to on. No? The maximum is, I think, that is 2 volts. So 10 volts is being dropped down to or being used by resistor. And for the regulator is to make sure that the output voltage is constant to 12 volts or whatever voltage that we need in our load. Okay, so next is we'll discuss what is a transformer. A transformer is an electrical device that uses electromagnetic induction to pass an alternating current signal from one electric circuit to another, often changing, okay, or transforming the voltage and electric current. So transformers do not pass direct current and can be used to take the DC voltage, the constant voltage out of a signal while keeping the part that changes the AC voltage. Usually, this is the one that we use in the inverted circuit or the inverter because we're using 12 volts DC, but the output is 220 volt alternating current. Okay, these are the images or examples of the images of a transformer. These are the usually used transformer. In electronics, these are the small type of transformer or step transformer, and the electrical usually we can found it at the pole, no, or the post pole. This one and this one are located at the power source or the usually the Noreco and our province. Okay, so inside the transformer, we have here the transformer core, usually the metal core, and we have here the this one is the magnetic wire, being wind. This is the primary and this is the secondary. Anyway, we are not going to focus inside the transformer. Okay, the electronic symbol of a transformer is this one, usually for center top. So this is called center top because it could be a common top, or we have 12 volts, then 1, then 0, then we have 12. This is 220, the primary winding, and the secondary winding is a step down voltage. Example 12 volts, 12 volts, 12, 0, 12. Okay, the diodes. By the way, I'm going to discuss later the video presentations of how to test the transformer using VOM or multimeter. And also diode, and I'm going to show you also the waveform. Okay, diode is an electrical device allowing current to move through it in one direction with far greater ease than in the other. So the most common kind of a diode in modern circuit design is the semiconductor diode. Although other diode technologies exist, no? We have GaN diode, Schottky diode. Semiconductor diodes are symbolized in schematic diagrams such as the figure below. So the triangle one is represent the anode or the positive terminal, and this one is the vertical line is the cathode side or negative terminal. In the real diode, so the white one side is the negative, and the uh, black side is the positive. Now, diode biasing. The purpose of biasing is to enable the negative side of the sine wave of the transformer is being black and the positive side is being allowed to pass through the diode. So reverse bias, the junction diode. When a diode is connected in a reverse bias condition, a positive voltage is applied to the N-type material and a negative voltage is applied to the P-type material. So in this diagram, as you'll notice that the N region or the negative N stands for negative region, and P stands for the positive region. It is called negative or the reverse bias because our positive side of the battery is being connected to the negative or the region, the N region of our diode. And the negative is also connected to the P or the positive region of the diode. So as you have noticed, from Coulomb's law, no, unlike charges attract each other and like charges repel each other. Now, as you have noticed that positive and negative are unlike charge, no, or unlike sign. So unlike charge is attract each other. So as you have noticed, this positive side or the terminal of your battery is going to attract the negative region or the N region. So it happens that these all negatives are being pulled out, pulled out or attracted to the positive. So what happens is inside these diodes will be empty. When you say empty, all the negatives, uh, s- all the negative charges are being attracted or being pulled out. When we say attracted, in Visayan terms, gikuha siya, no? Gibira. Gibira siya ang imong negative paingon sa positive because they are unlike signs. So unlike signs is attract. So the negative one will attract to your positive. So all negative regions or all negative charges will be paingon rin sa ato ang positive. And the positive also is supplied with a negative, no, sa imong battery. So may tabuan no, ang imong positive i-attract mo na siya sa imong negative. So tanan nga mga charge rin positive paingon sa imong battery and ang imong mga pong negative sa imong diode paingon to sa battery ang may tabo there could be empty or no charges uh, inside the diode. So this is the equivalent circuit, no, as a switch nga ang imong diode inside sa imong diode karon is open. So when we say open, so there could be no flow of current. So it means that the diode is already at open condition or kung sa switch mo na siya, naka-off na siya. So ang mga suga na naka-connect in series ani niya, hindi siya musiga no because wala flow of current inside the diode. So we are going to discuss also, we're going to have some video presentations why if we're going to reverse bias your LED, because LED is a type of a diode, the LED will not light. And if we're going to forward bias, then the LED will light. Okay. So next is the forward bias. So the forward bias is the opposite uh, biasing of your reverse bias. So this is the by the way, a forward bias when a diode is connected in a forward bias condition, a negative voltage is applied to the N-type material and a positive voltage is applied to the P-type material. If this external voltage becomes greater than the value of the potential door, approximately 0.7 volts for silicon and 0.3 volts for germanium. Okay, so usually the element or the that is being used in industry is the silicon one, usually 0.7 volts ang yung potential barrier. Okay, so the potential barriers oppositions will be overcome and current will start to flow. And once nga ang imong supply nga voltage is greater than this barrier voltage, so the diode will uh, close circuit or will operate. So there could be a flow of current inside your diode. So this is the diagram, simple circuit diagram. So our negative side of our battery is supplied to our N region of our diode. And the positive is supplied to the P region or the positive side. Now, according again to Ohm's law, no, to Coulomb's law states that like charges repel and unlike charges attract. So as you notice, positive supplied to the positive side of your diode. So they are positive and positive, they are going to repel each other. So when you repel, balik itulod niya ni ang imong positive sa diode, no? So, kaning positive sa imong battery mo tulod na siya, no? Yan na i-push ni imong positive to the negative. And ang imong negative also sa imong battery, supplied sa negative sa imong region sa imong diode, iya mo na i-refill. Yung sa refill, iya na itulod. Now, as you have noticed, ang imong negative moving this one, ang imong positive to moving that one. So, ang negative region sa imong diode ug ang positive region nag-attract to each other. When sila attract each other, nagtapot na sila within this area. So, ang nitabuan na ron, there could be a short circuit. No? This is short circuit na ang imong inside sa imong diode, ang imong negative side and ang imong positive side nag-attract to each other. No? When they attract each other, nagtapot. So, there could be a short circuit inside sa imong diode. When there is a short circuit, so there could be a flow of current. So, the diode will now act as a conductor. The conductor sa atuang circuit. So, mara siyang purpose na sa diode. Open siya if reverse bias. Open siya pag reverse bias. And close siya pag forward bias. So, forward bias, no? Pag positive, supply po mo sa positive. And negative sa imong battery, supply po sa negative sa imong diode. And ang reverse, ang negative supply sa positive and ang positive supply sa negative para birahon niya ang negative region or charges sa imong diode paingin sa positive sa imong uh, battery. Okay, then these are the samples of images of diodes. So this one are called the rectifier diodes. Inside of this rectifier have four diodes. This one also four diodes inside this rectifier, and also this one four diodes. We're going to discuss that later, no? Components inside electronics. And these are called the chip diode. This one, no? Or the surface mount diode. And this one is the LED, the lead, the chip lead, and this one is the jumbo type lead, and this one or the light emitting diode. And this one is the usually the semiconductor diodes that we are going to use in our tutorials. So the negative one is this one, the white color sa to ang diode. So kanin siya, if this is the white and this terminal is negative and this one is the positive or the anode side. And this one is a sample of a zero diode or the regulator diode. Okay, this one again, that is the negative and this is the positive. This is the negative and this is the positive side. Okay, next is the capacitor. The capacitor is a component which has the ability or capacity to store energy in the form of an electrical charge, producing a potential difference static voltage across its plates, much like a small rechargeable battery. Only, they are the same to battery, but the discharge time is very fast compared to a battery. And there could be another video tutorial of this one. So one video tutorial for a transformer, one video tutorial for a diode, one video tutorial for a resistor and an LED, and one video tutorial for a capacitor, and another video tutorial for a regulator device. So the last one that we're going to discuss, so these are the sample or the images of a capacitors. So these are the electrolytic capacitors, the varicap, so electrolytics of the what we call this one. It could be polarities. They are positive and a negative. This one is negative and positive. And the varicap or the variable capacitor. And this one is the ceramic. and in Mylar, and so on and so on. Okay, the last one is the resistor. Ano, anyway, resistor is an overall discussion. So the resistor is a passive. When you say a passive, it also depending on the value na kinahanglan niya para to oppose the flow of current. So it's a passive electrical component to create resistance in the flow of electric current. In almost all electrical networks and electronic circuits, they can be found. So the resistance is measured in ohms. An ohm is the resistance that occurs when a current of 1 ampere passes through a resistor with 1 volt drop across its terminal. The current is proportional to the voltage across the terminals of. Okay, so these are the sample of the images of resistors. Then the last one is the voltage regulator, or the final stage of our basic power supply. So a voltage regulator is a system designed to automatically maintain a constant voltage level. So a voltage regulator may use a simple feed-forward design or may include negative feedback. So feedback is another type of topic that we can discuss. It may use an electromechanical mechanism or electronic components. In our example, we're going to use only the 78XX or 78 series of regulators. So in this example, so the 78XX, the pin 1 would be the input and pin 2 would be the ground and pin 3 would be the output of our circuit.